Hello guys, today I'm going to talk about the theory of relativity. So, the theory of relativity is actually kind of easy. Well, this is how it works. So let's say you're going in a shopping trolley or a train, and you see, I don't know, the big London bell, as you can see here. Since our eyes see what light is reflected upon, for example, let's say you're in a dark room, you can't see anything. Why? Because light isn't reflecting on the surface and then into your eyes. Since light is what powers the room, so you can see things. But if you can't see anything, then that's why it's going to be dark. In the room you're in, it's dark because there's no light. Light is not reflecting upon the surface. This is the same thing here. If you're going in a train at light speed, and you look at that that clock, since light isn't able to reach the clock and reflect in your eyes, you aren't able to see the image. So, in a sense, that image is still, and you can't see anything. Since let's say it's 10 o'clock, and then your trolley suddenly zooms at light speed. Since you're traveling at light speed, the light isn't able to reflect since you're going at light speed. So even after 1 hour, the clock will stay the same for your eyes. But when the trolley comes to a stop, then you'll be like, "Oh my God, it's 11 o'clock already." That was basically 1 second. That didn't take any time. That's basically how light works. Same with something like this. Light is, well, it's kind of like this. Speed is proportional. For example, let's say there's a train, and there's another train. This train is going 20 miles an hour, while this one is going 40 miles an hour. To a person in this train, that train will only look like, if he didn't know this train was going fast or moving, he would only see that train was going 20 miles an hour. But in reality, for a person standing in the middle, he would see that train is actually going 40 miles an hour. Since this train is going 20 miles an hour, 40 minus 20 is 20 miles an hour, and you will see 20 miles an hour. But let's say there's something like this. You're going 20 miles an hour, like this train. Another train is going backwards at 40 miles an hour. Then what would happen? Since you're going at a speed 20 miles an hour plus the 40 miles an hour oncoming train, it would look as though that train is going 60 miles an hour, when in reality it's only going 40 miles an hour from a person standing in the middle. Or kind of like a car on a freeway. The cars, when you're going, there's cars going forward and then back. If you're standing in the middle, any car, left or right, will only look like you're going 60 miles an hour. But if you're traveling in one of those cars which are going 65 miles an hour or 60 miles an hour, the car on the left side, which is opposing you and going straight towards you, would actually going 120 miles an hour to you. That's kind of like how Earth worked for at least the 15th or 16th century, before they knew that Earth actually rotated. People thought that Earth was stationary and everything orbited Earth, when in reality, after telescopes and new technology inventions, people realized that actually, in reality, the Earth was the one that was moving. Light only goes at 299 meters a second. So yeah, it's kind of like this. Same example with the train. To a person who is like, let's say there's two lightning bolts like this, left and right, and train's going light speed. To him, the closest one he would only see the closest one, lightning bolt. But Einstein would see both of them because he's stationary. He's not moving anywhere. So E equals mc squared. He also mentioned that there's a space fabric, and this space fabric